Actually, I would like to say my special thanks to you for inviting me on this show. Okay, so I'm known as Izmir Yamin. My full name is Muhammad Izmir bin Yamin. So I am an aerospace engineer. I studied mechanical and aerospace engineering, and I also did business administration in the US. So after I graduated, I worked about 3 years in the aerospace industry within the Airbus aircraft program. So I was an aerostructural engineer back then. So there were a few prior to starting my own company. So after 3 years of working, then I started a drone and a space company. We are developing back then when we started in 2013, we developed special technology revolving around the product, which is hydrogen fuel cells. So hydrogen fuel cell is known to be one of the best energy. If we compare with batteries, it can run longer than batteries, and it is electric, also green as well. So we were developing this product for the drones, and in terms of the space company, we were focusing more on space transportation system, which covers both launch vehicle and re-entry vehicle. So a lot of these projects, they have been conducted locally with the local R&D. So we have filed in a lot of patents, including US patent as well. Today we are looking into servicing our clients both in the drone and the space industry, both locally and globally. So recently we have managed to close a $1.1 million deal with a Dutch company in selling our product, which is a re-entry capsule vehicle. That would actually help those companies conduct their biotech experiment in orbit upon several days and returning safely back to Earth. So this is the kind of missions that astronauts would usually do, but we conduct for the customer unmanned missions so that they can reduce their cost tremendously. Having said that, it's a high in demand right now. Very handful players in the world are doing these services. And then besides that, we are also embarking on a launch vehicle program. So where we anticipate in 5 years down the road, we would have a rocket launch vehicle that is able to launch satellites into low Earth orbit. And subsequently, we are going for a higher orbit and eventually interplanetary missions. So as we speak right now, we are at 30% stage of developing the high booster rocket engine. Everything is developed and made locally from design until manufacturing. So even the rockets that we develop are quite unique in a way that we use localized fuel. So this localized fuel is utilizing local biogas converted into rocket fuel. So we can take advantage from the agricultural waste and municipal waste, things like that. So that makes our rocket the world's first net zero carbon rocket in the world. So these are the two main transportation system within the space company. And both of them are powered by hydrogen fuel cells, which makes our product much favorable due to many reasons. One, it can have a better energy density, which means lighter systems, more efficient, and we can increase more payload to compensate with the heavier battery if it were to be battery-based technology. So even for our drones, we also use hydrogen fuel cells. Actually, if you want to understand how hydrogen fuel cell works, technically it's like a battery, but the only difference is this is air breathing. So it's almost like a piston engine and a battery. So hydrogen fuel cell takes in oxygen from the air and hydrogen from the fuel tank. It will convert that directly from chemical into electrical power. So there's no combustion, there's no moving parts, it's just direct conversion. Unlike petrol, you have chemical, and then convert to heat mechanical, then you have your output. So this is, we skip the heat and mechanical part, which means there's no vibration, no vibration, not great heat output. So yeah, it's very favorable. So what we do in our company, mainly we do research on the fuel infrastructure to be put on board the transport and vehicle. So we generate our own reactor system, which is very small particles down to the nanoscale particle. So you're talking about 5 to 30 nanometers in terms of size. And we have successfully cracked the code in having a ultra long endurance system. So the technology will be demonstrated on board our drone, where we plan to fly across the South China Sea, running from Johor to Sarawak. So non-stop electric flight.
Wow.
So I think this will be, thank you. So this will be second in ranking after the world global flyer called the Helios, which is running on solar power, which ran for close to 54 days. But the difference between our system and theirs, ours is much compact, smaller, very day-to-day use type product. Theirs is about So I think that will be the differentiator between the 54 days of their solar power flight mission versus our 9 to 10 hours flight mission. But we are going to do a showcase early next year to demonstrate to our customers, which, by the way, we already have 2 customers, both local and abroad. So we are talking about customers from the Netherlands and Germany. They're looking into purchasing these drones for their internal purposes, both in surveillance and agriculture. So we have companies local as well to do mapping services within the agriculture sector. So I think what we are doing is we are addressing the pain points of the industry that using such technology, which is flight time. So we are doing our R&D to solve the flight time endurance issue in all of our products, from drone, re-entry vehicle, capsule, and also launch vehicle. Yeah, so I think that pretty much our backbone and the core technology that we bring forward. So if we were to sum up, we would introduce ourselves as a deep tech company that covers both the aviation in drone sense and also space in the unmanned sense. So yeah, space transportation company.
Okay, thank you, Izmir, for the introduction about yourself and also about your company and your businesses. Okay, and for the next question, okay, what is the biggest challenges that you have faced in life and your career, and how do you bounce back? How do you bounce back from the challenges?
Okay. I think one of the biggest challenges is to be surviving the circle and environment that sometimes would have a different mindset than yours. I think we would say like-minded people are quite scarce these days. So what I would normally do is I would look into conferences, international events that would gather all these kind of like-minded people, and I would go and attend them. So I would tend to make more friends globally with similar situation that I am. Then we would exchange ideas how we go about dealing with the issues, because they also have similar issues back in their home country. So I think that actually is like peer-to-peer consultation, idea sharing. I think that helps a lot. So here in Malaysia, I think a lot of things that we do are quite pioneering, because it's not only has not been done in Malaysia, it has not been done in the world at certain points. So I think that's where the validation from the society is not that straightforward. So we always believe in show and tell. So we like to do demonstrations, technology showcase, and then of course when we do so, we will always go with a third-party verification, and we like to be genuine when we showcase. I think that's the reason why customers from overseas, they have the tendency to subscribe to our services, to our technology, because of that track record that is very transparent from our side. In fact, later when we talk about the satellite, I will also share some things that is quite exciting. It's happening next week on Monday at the Malaysian Space Center in Banting. So I'll share that shortly. But in terms of bouncing back, I think it all depends on the smallest validation you can get, especially from like-minded people, like I mentioned just now. Yeah.
Okay, and for the next question, okay, the world's smallest satellite has been validated by renowned space industry experts. Yeah, it is smaller than the pocket cube and has similar functions and significantly smaller than a CubeSat. Congratulations to you and your team on the launch of Gerhanasat, and you make all of us Malaysians proud. So can you share with us more about Gerhanasat?
Okay, thank you so much for the kind wishes. Actually, Gerhanasat came into ideation because we are trying to solve one particular problem. And that problem is communications in the plantation area, in the rural area, and also the remote areas. So when we talk about communications, we talk about communications for drones that were to do missions in those areas, where when the drone flies much further down, further away, communication will always be a challenge, because due to the geographical and the terrain that will block out the signal. So oftentimes people will resort to third-party communication relays like telco towers, paid satellite services, which is very, very expensive, and then high towers, mesh network. So oftentimes these are all giving a lot of different dynamics of headaches. So what we trying to do is trying to empower all these machines and devices, especially drone and IoT devices that is widely used in plantation, by providing them the necessary bandwidth that they need. Typically, they are ranging from 2 kilobytes per second all the way to 10 kilobytes per second. Give them the necessary bandwidth they need at low or no cost. So that's when we came about the idea of why don't we leverage on the geographical location that we are in, which is the equator, and launch a satellite that will provide continuous daytime communication. So as long as it's daytime, you will get continuous communication. So it's like if you talk on the phone, there's no call drop in between. So that's what we envision, so that during the day, the farmers, the workers, whoever needs the kind of communication they need, could actually leverage on this system. So how does it work? Since we are on the equator, if we were to launch a satellite into low Earth orbit, it would revisit us above our head every 90 minutes. So that would be like 14 times a day. So if we were to have a continuous presence of satellite above our head, we would need to launch only 108 satellites. If we were to be in America or Australia, which is northern and southern hemisphere, we would need more than 650 satellites. So I think it's quite a blessing that we are spot on the equator. So we need lesser satellites. And we have 14 overpassing a day, unlike the northern and southern hemisphere. Sometimes they will have once a day passing. maybe every 2 days once. So it depends on their latitude. So this is quite a blessing. Every single day is a constant overpassing. When I say overpassing, meaning the satellite will pass above our heads only for 10 minutes, and then you don't see it again after the next 80 minutes or so. So that's the situation. Okay, so the satellite that we are talking about is called Gerhana Sat. Means Gerhana means eclipse, right? So for now, when we do a constellation meaning we have satellites that are equally spaced around the globe. Okay, and in this case around the equator. So that would become a relay for communications. Let's say we fly a drone in the plantation, namely oil palm. So oil palm has a huge hectareage, and we want to communicate the drone with the drone, like, I don't know, 100 kilometers away, without the worrying, without to worry about terrain issues. We can actually, from the base station, we can point up to the satellite. Satellite will beam down the signal back to the drone at a rate that is speed of light. So then we are able to tell the whereabouts of the drones, give commands to it. If, let's say, any problem happens, we can send command back to come back to the base. So it will make the operator of the drone piloting much easier. When you have IoT devices right now, it's quite hard for them to communicate once you put like pH soil sensor in the ground. And then you have some other sensors for the crops that you would need to send back data to the base. You would need to latch on a communication network, which is sometimes costly, not available. So with this Gerhana Sat, it can provide that communication wherever you are in the equator. So I think this is one of the key motivation why we want to launch this satellite. And then the word Gerhana comes from when we were doing the designing of the orbital mechanics. We saw a ring around the globe, combination of all the satellites around the equator. And then when we look from the north or south,